All right, hopefully you took a minute to try the Got It C on your own. Let's take a look ourselves. It says ticket to the school dance costs $5 per student. Are the ticket sales a linear function? Explain. So let's look. This goes up by 1. This goes up by 1. So for the number of tickets sold, that checks out. This goes up by 5. This goes up by 5. This is the same amount. So I'm going to go ahead and say that it is linear. My explanation is it has a constant rate of change. And that's all you have to do. You just have to say, are these numbers the same or are they different? If they're different, that's your explanation. It's nonlinear. If they're the same, that's your explanation. It's linear. So in example 4, it says a square has a side length of s inches. The area of the square is a function of the side length. Again, here's a lot of words. Ultimately, they're going to ask us to make a table, graph it, and look and see if it's linear or not. Okay, we know how to make a table. We've been doing that. Pick some values, plot the points. I can see that this is not linear. It's not linear because it's not a line. So let's go ahead and do the guided practice together on page 330. So in the table, in number 1, we're going up by 1, by 1, by 1. Since all of these go up by 1, x checks out. This goes up by 2. This goes up by 3. This goes up by 4. So that is nonlinear. Changes by different amounts. Now let's look at number 2. Goes up by 3, goes up by 3, goes up by 3. So all 3 of those are going up by 3. Oh, this is tough because it has a negative, but we can handle it. So from -3 to +9 is plus 12. From 9 to 21 is plus 12. From 21 to 33, that's plus 12. So that one is linear, has a constant rate of change. And that rate of change, if we wanted to get technical, would be 12 over 3 or 4. That's our slope. We've learned about that in other sections. So number 3 wants us to do the same thing with the table they give us. All right, so this goes up by 3. This goes up by 4. This goes up by 2. I can already tell that this is not in any way linear. So I am going to say it is nonlinear. Changes by different amounts. It's not going well. There's no pattern there at all. Number 4 says a cube has side lengths of s meters. The volume of the cube is represented by the expression s cubed or s to the third. Is it linear or nonlinear? Now, what I could do if I wanted to, if I wasn't quite sure, is I could make myself a table where I have some x values, and then I would do x to the third to get my y values. So for example, if I picked 1, 2, and 3, I would end up with 1, 8, and 27. It is not linear. I also know that it's not linear because it has an exponent. Remember, exponents mean it is non-linear. We'll finish this up in the next video.